Okay, so in this video, we're looking at 3D problems. We're going to be solving 3D problems with trigonometry. So a 3D problem does what it says exactly on the tin. It is a problem that's in 3D, but unfortunately, paper is 2D. So we have a 2D representation of a 3D problem, and then we are asked to solve it. So tips for solving 3D problems, yeah? If we're given a diagram, make sure we name and label all the vertices, like vertices in the name for points or corners of a shape. We also have to decipher triangles that we can work with, right? So it's very handy if you use like different colors or etc. We're going to be doing a lot of sketching of triangles. We have to remember, if we're using Pythagoras or sine, cos, tan, like our trig ratios, we can only use them on right angle triangles. And we have to remember our cosine rule and our sine rule as well. The key main takeaway point would be, if a vertices or a point is vertically above the ground, it is considered at a right angle to the ground. So you have to look out for words like vertically above or perpendicular to the ground, etc., etc. So let's have a look at this problem here. So this problem is a 3D problem with shapes. So we have a cube here. So a Rubik's Cube has the dimensions 5.7 centimeters. So it's a cube, so all sides have the same length. Part 1 is asking us to find side AC. So AC, if you look here, well, this shape here at the top is the top of my cube. So we're looking for AC, which is kind of the diagonal of my cube. So I need to kind of make a triangle from this. So I'm going to make triangle ABC because I'm going to know the sides of AB and I'm going to know the sides of BC. So let's draw out this triangle here. There's my right angle triangle. Label your points. So B is where my right angle is. So remember, this is a square, so that's obviously a right angle. And I'm going to label this A and label this C. So we're dealing with a cube. So this is obviously 5.75 centimeters, and this is 5.5 centimeters. So, and then this is length AC. Now we're trying to find AC. I have a right angle triangle here, so I can use Pythagoras. So I know AC squared equals 5.75 squared plus 5.75 squared. AC squared is going to equal to roughly 66.125. And then square root both sides, I get AC is equal to 8.132 centimeters. Now, make note of that length because realistically, it probably will come up in a later part. So let's look at part 2. Part 2 is asking us to find length AF. Now, if you look at the shape here, AF, so F is kind of like my front right corner, my front bottom right corner. This is the front bottom of my cube. A, if you can see it, A is kind of like the back upper left corner. So I'm looking for AF. So I'm looking for the length AF. So I have kind of this kind of shape here. I'm going to call this back vertex H. Right? I kind of have a right angle triangle here. And this is going to be a right angle because A is kind of, it's a cube. So it's kind of vertically above. So I can confidently say this is a right angle triangle. So let me sketch out another one here. Again, labeling your corners or labeling your vertices. So this right angle here, I'm going to say is H. A is on top and I have F here. Let's fill in now values we know. A to H is a side of the cube. So I can say this is 5.75. Then HF. Do I know any other information that can help me find HF? Well, if you kind of look up here, AC is the diagonal across one of the square faces. That's the same with HF. It's the same thing. So I can say HF equals AC. So HF is equal to 8.132. And I'm looking for AF. Again, I have a right angle triangle, so I can use Pythagoras. So AF squared equals 5.75 squared plus 8.132 squared. So put all that in your calculator. You're going to get AF squared is going to be equal to roughly 99.1919, so something repeating. Square root both sides. You're going to get side AF is going to be equal to roughly 9.96 centimeters. How fun. Right, so that's the second part. Let's go on to the final part now. The final part is asking us to find angle AFE. So this is a tricky one. So it's asking us to find angle AFE. So let's draw a triangle AFE. So I'm going to use blue. Actually, I'll use red. I don't know which one won't come up. Blue, right? So I'm looking for A, E, F. So you're going to need to adjust your eyes here for a minute. I'm going to rub out this the workings for part 2 now. I'm going to rub out my workings here. And that was side C. So I'm looking for the angle AFE. So I'm looking for A, I'm looking from A to point E. So AE, the diagonal across one of the square faces, E to F. And then I'm now looking at the diagonal A to F. So it might look like it, but it actually is kind of like a right angle. It is a slanted kind of right angle. It's kind of being just kind of leaning out, leaning along the back wall. It's leaning along the back wall of the cube. So let's draw it out. A, E, F. Let's fill in the information we use. So I know what AF is because I knew that from part 2 because that's what I calculated. A to E, however, A to E is the diagonal. Is the diagonal of the back wall to here. So this diagonal shape is the diagonal of one of the faces. That's what we calculated. It's the same as AC. So I can say that this is equal to 8.132. And then finally E to F, well I know E to F, that's just the length of one of the sides of the cube, so I can say that's 5.75. So I have 3 values here, so I can use any of my ratios, sine, cos, or tan. So I'm going to choose, for the sake, cosine, right? So I'm going to choose cosine of the angle F. So I'm just going to say cosine F to kind of indicate I'm using angle F. So remember cosine, oh hell, another hour of algebra. So A over H, so adjacent over my hypotenuse, 9.96. Angle F is equal to cosine inverse 5.75 all over 9.96. And therefore, angle AFE is going to be equal to 54.74 degrees. So that is just an example of a 3D shape, of 3D problems where we're kind of working within a cube or prism or a cuboid, right? Another one I want to look at now is this one right here. So we're dealing with a helicopter. So this is from the 2011 Leaving Cert. This is part C of a question. A and B are 2 helicopter landing pads on level ground. So A and B, these 2 here, these are landing pads for the helicopter. C is another point on the same level ground. BC is 800 meters. So the length from B to C is 800. So let me fill this in my big diagram here. You see why I colored it in there in a minute. Then I know A to C is 900. So A to C is 900. And then BCA is equal to 60 degrees. So BCA. So this angle here is 60. And then helicopter D is hovering above A. A person at sea observes the helicopter to have an angle of elevation of 30 degrees. So if you allow me here, that's 900. This angle here is 30. Find the length AD in surd form. So I'm trying to find AD. This is the kind of the height of the helicopter. So you see here I split into 3 colours because I'm going to be breaking this up now into 3 triangles now in a minute. The first triangle I'm going to break it up is this yellow one. So that's D, that's A, that's C. this helicopter is vertically above point A. So I can say it's at 90 degrees. Then this angle here is 30, and then this is 900. I'm looking for point DA. Do I have enough information to do that? Yes, I do, because I'm dealing with right angle triangles. So remember SOHCAHTOA. So sine opposite over hypotenuse. TOA. So I have my opposite and my adjacent. So I'm going to be using my tan ratio here. So I know tan 30 is going to be equal to dA over 900. Therefore, multiply both sides by 900. I'm going to get side dA is equal to 900 tan 30. Length dA is going to be equal to 300 root 3 when you put that in your calculator. Gorge. Right. Next one now. Find BD. So find BD. So BD is the length from here to here. So it's the diagonal distance from the helicopter to the second landing pad. So let me make my second triangle here. So this is point D, this is B, and this is A. I know what DA is from part 1, that this is 300 root 3, so that might come in handy. Then I'm looking for BD, and then I have no information on BA, so I'm kind of stuck now. There's nothing I can do with this triangle that could help me solve it. So is there another triangle I can look at here? Well, there is. This is grey one right here, right? This grey one on the ground. So this grey one is a flat triangle. So this triangle is just flat on the ground. It is from the pad A, pad B, and then this point over here. So this is flat on the ground. So there's no right angles or anything in this one. So let's draw this out. So A, B, C. Now, if you reread my question, I believe I have a bit of information here. So BCA is 60 degrees, so that angle there is 60 degrees, and the length BC is 800 meters, and the length AC is 900 meters. So, looking at these two triangles, what can I see? Well, this side BA is going to be the same as that side BA. So do I have enough information on this triangle to help me solve for this one? And indeed I do. So I'm going to be using the cosine rule because I have two sides and the angle trapped between, so I can use the cosine rule. So remember cosine rule, we label our unknown sides A, so that's going to be A. Let me do this in a different color. That's going to be A, that's going to be my angle A, and this is going to be B, and this is going to be C. So, let me solve it now. So A squared is going to be equal to 900 squared plus 800 squared minus 2 times 900 times 800 cosine 60. If you put the left hand side in your calculator, you're going to get A squared is going to be equal to 730,000. Therefore A or BA is going to be equal to the square root of 730,000. So now to have this information, to 730,000, I can solve for side BD. And how can I solve for side BD? I can use Pythagoras. I can use Pythagoras because I have a right angle triangle. So I know BD squared is going to be equal to BA squared plus DA squared. So BD squared is going to be equal to BA squared. So all this squared, well, squaring a square root just gets rid of the square roots. So it's going to be 730,000 plus, and then DA squared. DA squared or AD squared, whatever you want to call it. That is going to be equal to, so 300 root 3, square that on your calculator, 300 root 3 all to be squared, you're going to get 270,000. So you're going to get length BD squared is equal to a million, 2, 3, 4, 5, 6, a million meters. Therefore, BD is going to be equal to the square root of a million, which is going to be 1,000 meters. How fun is that? So, really like this question. Right, so it allows us to use our sine rule, our cosine rule, etc. So it's always very important. We're always looking at things that are vertically above, because that means we can use right angle triangles, right? Always trying to decipher right angle triangles, and always remember sometimes triangles are flat on the ground, and try and utilize them as well in your answer. Make sure you always sketch out diagrams, make sure you always link in or color up what sides have in common. Sketch, sketch, sketch. Maybe like if you're not enough space, go to the back page, sketch out the problem in your head, right? Like use your pens to model what's happening within the problem, right? So the key to 3D problems is practice, 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 right? And so yeah, I hope this video was some help to you guys, and I'll catch you guys later. Bye.